at finding unknowns with combinations, which isn't commonly done, but it can be done. So here's our question. 4 times the formula of n choose 2 is equal to that same n plus the number 2 choose 3. So it's saying that these two equations are equivalent. Now we want to make sure that we understand this this way of writing it, the symbolism they use here. N over r, or n choose r, is equal to n factorial over n minus r factorial times r, and that's a factorial there. Okay. So what we're going to do is we're going to use this equation for both the left and the right side of the equation here, because there's an equal sign, and we're going to plug our values into this, and we're going to set the two equal to each other. So our left side will be, I'll write this in right, so this is our left side of our equation, and green will be our right side of the equation. Okay, so our left side, I'll write the equation out first, n factorial over, and recall that we used n for n, so n won't change, right? And again, our r value is the number 2, so n minus 2 factorial, okay? And our r value is 2 again, so 2 factorial. So we have all that, and that's technically all multiplied by the number 4, okay? So number 4 is kind of outside of our bracket. This is equal to, and our right side of the equation, same idea. In this case, we've replaced n with n plus 2. So we have n plus 2 factorial over n plus 2. Okay. R is the number 3, so subtract 3 factorial and times 3 factorial. I'm going to just bring this out. Does this kind of make sense? The n here was replaced with n plus 2. Okay. And the r was replaced with the number 3. Okay, and let's end those brackets. Okay, so now we've set together all of our equations. Let's kind of try to go about eliminating as best we can and simplifying as best we can. Okay, so I'm going to focus on the left side to start. I didn't want to use green. We're going to focus on the left side of this equation to start. We have our n factorial on top. Okay. And we have our n minus 2 factorial on the bottom. So we'll think about this idea. Imagine the n was, I'll write it on the side. This will be our side calculation. Maybe n was the number 5, right? So if we had 5 factorial over n minus 2, well, that'd be 3 factorial. We know we can write this out by 5, 4, 3, 2, 1 over 3, 2, 1, right? So the 3, 2, 1s all cancel out, and it would just be the two numbers, the first and the second down. So with that being said, and I'll kind of write it out in the actual ways it's written here, but we still have our 4, okay, times, and I'll write this out. This would be n times n minus 1 times n minus 2, okay, dot, 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 all the way to the number 1. Divided by, well, the bottom would be n minus 2 times n minus 3 dot 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 all the way down to 1, and then again times I'll kind of put in a bracket here, 2 factorial. So this is just the right side of the equation. Okay, well, with that being said, our n minus 2 all the way down to 1 can kind of cancel out. Like we said here, all those numbers are going to be the same. So what's left on top is n times n minus 1. Okay, so I'm going to finish off the, oh, did I do my left and right wrong? Oh, that is left. Okay, good. The left side of the equation. We still have 4 times it, but this time on top we just have n times n minus 1, all divided by 2 factorial, which is 2 times 1, so it's just a number 2. Okay, so there's our left side. Our right side is a little different here. Let's see what we can figure out when we do this. The top will still be n plus 2 factorial. Okay, we're not quite sure how it's going to help us out. On the bottom here, you have n plus 2, and we can kind of drop the brackets, minus 3. So the 2 and the 3 are like terms. Okay, so this can actually, positive 2 and negative 3 is negative 1. So this bracket will be called n minus 1 factorial. Does that concept make sense? A little bit. It would be, I'll kind of show it a little more. And again, we'll still have our 3 factorial. What we did here on the side, I'll just do it in blue, is I did n plus 2 minus 3. Okay, so I simplified these two, and it becomes just negative 1. So it's n minus 1. That's all that's left in there. Okay. With that being said, now we have our plus 2. We can kind of do the same concept we did over here down here. Okay. Because a factorial constantly counts downwards, n plus 2, imagine it was the number, well, I don't know, again, number 5. If n was 5, well, plus 2, that would put us at 7 factorial, right? So we'd have 7 times 6 times 5 all the way down. And again, if n was 5, we said n was 5 here, n minus 1 would be 4. So it'd be 4 by 3 by 2 by 1. So again, anywhere from 4 all the way to 1 essentially cancels out. And you're left with quite a few numbers here. The way we could write that with these values, okay, think of it like this. We have n plus 2 times n plus 1, right? Because we always count down, okay, times n times n minus 1 times n minus 2, all the way down to the value of 1. Does that idea make sense for counting down? Okay, good. And then on the bottom, we have our n minus 1 factorial, so, that's n minus 1 times n minus 2, all the way down to our value of 1, and then still times 3 factorial. Well, that means from n minus 1 downwards, these guys all kind of eliminate each other. Okay, so, I know it's going to be a little ugly on the right here. You're left with, and I'm just going to write them in brackets, okay? N plus 2 times n plus 1 times n, all over 3 factorial. And 3 factorial is 3 times 2 times 1, which is the number 6. Okay? And then we'll write our left side out here. Technically, and what I'm going to do here is, actually I'm not going to distribute, let's keep it as is. So we have 4, and we have n times n minus 1 all over the value of 2. So I got a bunch of variables. I want to start to simplify things. So because this is times 4, to move it to the other side it becomes divided by 4. Because this is already a fraction, to move it to the other side, I would just move it to the bottom and multiply by the bottom. Okay, so there's a nice rule we can kind of say we've learned. So that leaves us with n times n minus 1 over 2 is equal to, and we still have our n plus 2, n plus 1, and n all over 24. Okay. Same with the number 2. I want to move this 2 over. So to move this 2 over, it would multiply because it's division here. So the 2 would essentially come up here, and then we can simplify these two terms. 2 divided by 24, okay, is just like 1 over 12, or think of this like becoming the number 12. So think of it as 2 divide 24 as a reduced fraction. If I divide both the top and the bottom by 2, then it becomes 1 over 12. And the 1 on top is not important, so we don't have to write it in. So we just have n plus 2 plus 1 times n over 12. So this 2 is kind of gone now on the left side. So now we have n minus 1. Still have a lot of stuff. I can start to pick and choose to eliminate things. I want to get this, I have an n on both sides. So if I wanted to bring this n over, it would be, since it's multiplication, I know it looks weird, you would divide by n, which means these guys would disappear. So I'm picking and choosing to make my question simpler for myself. I'm left with n minus 1 on this side, and really just a quadratic on top, and, well, 12 underneath. I can bring this 12 over, and that means I'd have to multiply 12 by both these terms. Okay, both by 12, which means I'll end up with 12n minus 12 is equal to n plus 2, n plus 1. This we can turn into a quadratic if we FOIL. Okay, we can turn it all into standard form. So n times n is n squared. N times 1 is just n. 2 times n is 2n. And 2 times 1 is 2. And we still have 12n minus 12 on this side. We'll collect our like terms, plus I'm going to move all this stuff to the other side because I want to set it equal to 0. So I get 0 is equal to n squared. These two terms together is 1 plus 2, so it's just the idea of 3n. When I move 12n to the other side, it becomes minus 12n. Okay. This positive 2 is the same, and when I move the negative 12 over, it becomes plus 12. I just kind of move them. I know it's you would move them to the end or whatever, but I put them beside the terms that are like terms for them. I'll simplify again. This ends up being negative 9n, and this ends up being 14. And we're in a situation where we can factor again. I need two numbers that multiply to 14 and add to negative 9. And it turns out negative 2 and negative 7 work out very nicely, okay? So you kind of got to go factoring rules, which now means, oh, very interesting. We get n plus, plus minus 2 and n minus 7. Because it's set equal to 0, we'll get two answers. We're going to set each bracket equal to 0. So n minus 2 equals 0 and n minus 7 equals 0. So this is interesting. We get n is 2 and n is 7 according to this, which means we can get two answers. So we did a whole ton of algebraic work, but apparently there's two acceptable answers here. 2 and 7 will both work for what we're doing here. And you can test them out by plugging it in to figure